everyone, welcome to New Tech Creative. My name is Miles and it's wonderful to have you here. Today's video we're going to be checking out my build of a CoreXY machine with a little bit of a twist, so stay tuned. So just before I go any further, a huge shout out to PCBWay for helping me with today's project. They offer some really awesome deals on PCB manufacturing, but they also do some really cool things such as additive and subtractive manufacturing processes as well. So if that interests you, go check out their website. But for now, let's get back into the build. A CoreXY machine is a really interesting machine. Now, the reason why it's really interesting is because it has a fascinating kinematic system which moves around the X and Y positions. Now, this is a CNC machine, but it isn't a CNC machine that you typically think of putting a spindle on top and cutting timber. This is more for use on lightweight manufacturing, so things such as using a pen plotter, using a drag knife, or even a laser cutter. But things that you'd typically see a CoreXY machine set up for is 3D printing. Now, the beauty of the CoreXY system is that you have the motors in a fixed position. They're not in a axis which is usually moving, so it takes the weight away from where you typically need to move it quickly, and also giving you the benefits of having a really lightweight system. And that's all driven by a really unique belt pulley system. So I'm going to go more into details about that soon. I really wanted to create a CoreXY machine just out of the beauty of exploration and learning something completely new and a different type of system. So the reason why I wanted to create a CoreXY machine is I was really curious about the kinematic system and how it works. I also had a lot of spare parts lying around that I wanted to use and put into another project. So this was really the perfect project for me to push forward and create my very first CoreXY machine. Now, there was a lot of problems on the way. I haven't built it yet, so I really don't know if this is going to work, but fingers crossed, it's all good to go. And I've come up with some really unique ways on how to reduce wiring and make this system probably as fast as possible for the size of the machine I'm going to create. So what I've done already, I have created a concept of a corner of the design. Now, the reason why I wanted to create this concept is just to check to see if my prototyping was correct and everything was ready to go. So it's going to be a machine that spans across 1500 and by just over 1 meter wide. But I wanted to firstly see how my motor system would be going together. So this is a type of system that I've seen in things such as a laser cutter, where you transfer the movement through this belt pulley system, just using the shorter belt to convert the motion from a motor to the main axis. Now, the reason why I've gone with this instead of direct axis, it is essentially just one-to-one transfer of the motion, but I wanted to try and reduce the size of it. You can imagine that the motor would be placed upside down here, the machine would be starting to get quite tall. So I wanted to kind of create this streamlined effect that the motor was somewhere within the frame itself. So a lot of this build that I've gone with today is I'm trying to keep the build within the machine or the C-beam itself and just have it raised off the table a little bit. That's just to keep an eye on the streamlining of the system to make sure it's not getting too tall. And if I wanted to put it in some type of box or enclosure later on, I didn't have to build that out too far. So I put this prototype together so far just to check to see if this system worked, and it works really well. So this is the main shaft that will drive the belt pulley system, and this is the motor that will be creating it. So I'm using these NEMA 23s. Now they're a closed loop system, so they should work really nicely with this type of system and give it some nice feedback, and also be able to control this really quickly, and also be really good at the precision movements as well. So I have seen types of systems like this that uses servo motors instead. The reason why they use servos is because they move really fast, but the downside of servos is they can't do micro movements very well. So the precision of them isn't as good, but the speed of them is better. However, stepper motors aren't very good at moving fast, but they're good at precision. So these hybrid motors, these closed loop motors, are like a best of both worlds. And so I'm going to see how these go with this build, and I'm really excited to see how fast they go because I've used them on my Matilda CNC. So if you want to check out that series, click up here. I have used them on my Matilda CNC and they work beautifully. They work really quickly, but they also are really good at all those micro movements too. So this is the main concept. There were some issues with the 3D printed parts. I was considering about using aluminium pieces for these, but then I thought, well, it would be better if anyone else wanted to build it, that they had a 3D printer, they could also build this as well. So I've tried to keep it all 3D printed, but my first prototype that I can see here is that the motor mount really was a bit wobbly, and I'm not really happy with this, but I've updated that and I've re-3D printed these parts to make them much stronger and work a lot better with these motors and that transfer of motion. So let's get started with the build, because I'm really excited to get started and get this thing built to show you the awesome capabilities of this system. So let's go. So I prepared these off camera a bit earlier. So these are MGM 15C rails. These only come in a meter length, which was obviously a little bit of an issue, but you can see here I've just added on an extra part here just to extend them out to, I think it ends up being about 1450 length. There's a slight little jump as you go over the connections, but it's really not a big issue. It doesn't really stop the motion at all. So those have been preset, and I've also have put these little feet on it just to keep it up, and this should clear the motor because that motor falls under the C-beam a little bit. These should be able to hold them up, and so they're floating. So I'm going to go ahead and also mount the main frame, so the outer frame. You can see here I've already milled out the edges of these. Now these are for the belts to pass through, and I'm going to show you what that is in a second. If I was to redo this, maybe that these would be a bracket on the end instead of a spacer in the middle, so you'd actually add the extra extent onto the end of these. That means that you might not need to mill out any of these little C sections on the side for the belt pass through. So I'm going to go ahead now and assemble this. Just so I've got the main frame done. I've already mounted, this is for the end stop, and I'm going to show you a bit later on how that works. So I was just putting together this. This is the Z-axis carriage, and the issue is that it should have these little ripples on top and bottom of one side and then flat on the other. So I've had to go ahead and reprint this and also reprint the brackets that go on either side. So in the meantime, while that's printing off, what I might do is jump straight onto just starting to mount some of the electronics. Now the idea for the electronics is that I'm going to mount them down here on the front C-beam, just so that there is obviously really close to the motors, which is a really important part. And I'm just going to be using this root controller for this the control system for this using FluidNC. This is what I've been prototyping with, so there's a couple of cables here, but I've actually considered, and I'm going to talk about it a little bit later, but this is going to control both these motors plus the Z-axis, because for the moment I'm just going to test this without anything in the center, but then I'm going to add a servo controlled Z-axis in the center. So I've just been playing around with some ideas. I'm going to talk about this a bit later because it's really exciting. So I'm going to go ahead and just start mounting these. The beauty about this root controller is that these are perfectly spaced to go on to, I'm not sure if they're meant to go on to the C-beam, but they do fit perfectly with the hole spacing there. So this should be a simple enough solution. Might pop that right in the center, have the controllers for the motors or the motor drivers on either side, and then my power supply somewhere squished in here as well. So I'm going to go ahead and just start mounting these to get an idea of where I want them. Then hopefully the wiring should be super easy while I wait for the Z-axis to print. That should take a couple of hours. So by then I should have everything mounted at the front. So let's get started. So I've had a lot of issues trying to mount these 5M belts because I made this too far apart. I should have extended out. My original versions of these had much longer channels that I could slide the motor in and out. The new version had shorter ones because I thought I could get away with it, but it turned out to be a lot of issues because the belt was just too tight. So you can see here that I'm trying and trying. You can see the whole plastic part is flexing and the motor's starting to flex and things end up in the wrong directions. So it was just essentially a bad idea. But I mean, this is just a prototype, and I did want to do these in aluminium anyway, so the plastic part, I'm not too worried about it as long as I can kind of get the right dimensions now. So when I put the aluminium part together, then I won't have too much flex and too many issues with it. So I've just extended these holes out by an extra 5mm, and I think it's made quite a large difference in trying to mount these. These ones are 245mm circumference of these belts. So, all right, so let's try and just roll these over if I can. Oh, geez, that was an effort. All right, you can see how loose that is now. So what I can do now is really tension this motor backwards and get that tension on the belt. Not overly tight, not like I had it before. It should have a little bit of squish in it, but certainly that was much easier to mount than I had with the other side. So yeah, onwards and upwards. Here we go. Now I've gone ahead and replaced these, well, just extended out these holes, and man, that's made a huge difference. It's not as tight as they were, and this is much easier to move. So I'm really happy with that. I've finished up the rough wiring. You can see there's some still wires everywhere. I need to figure out there's too much wire for this really short distance here, so I might swap them out with some shorter wires. But I've also finished printing the replacement one of these. This is quite good because now I can go ahead and finish the center, the X-axis there, and this can go on and be mounted as well. So making a lot of progress today, which is really good. I reckon by the end of today I'll have everything assembled except for the belt, maybe the belt if I'm lucky, and hopefully even test the electronics before the end of the day, which would be good just to check that they are working. Yeah, making progress. All right, that went much faster than I expected. So everything's installed for the x-axis and it's moving really well. Sorry, that's the y-axis direction, and then the x-axis that way as well. So these are looking really, really nice. So you can see there that that's got the belt mounts. So when I attach the belts, that these clamps will go on top of them. Same thing on the back end, they'll be flipped around for the back end. That's why I had to reprint them, because I had stuffed up the which parts have the connections on them. These are really snug. They go into the MGM15s really nicely, nice and strong there. And I hope that when I put the belt on too, that will just secure that movement. But essentially that the physical build is now complete. Except for putting the belt on, and I just have to put the rear axles on as well, just for the guides to go on too. But I'm really happy so far with that, and I'm going to move on now to just tramming, or just ensuring that when it starts here, as it moves to the back. This was my challenge with this machine, was that as this axis moves backwards, you have to kind of align these rails in and out to ensure that they, like for example, if they're at the front, they might be really close together, but they might just be a tad wider at the back end, and they'll start to slow down. But so far they're looking pretty good. Let's get on to the next part. Alright, so I've plugged everything in. It's looking a bit of a chaos mess, but trust me, it's ordered. But as I said, that I need to reduce these wires. I just pegged everything up at the moment with some zip ties. Everything seems to be working fine, so I've got it connected to FluidNC at the moment. And if I just jog the motors, you can see that that's all same. It all tends to move fine. So I've already set this up as a CoreXY machine in the program. Obviously I haven't hooked up the main belts to go around the machine, so that's the next step. I'm really happy that everything's working. I've got the limit switches already wired in for the X and Y motion. I'm going to start with placing the huge belt. So I think it's about 5 meters per axis that goes around the machine, so it's about 10 meters of the 5M belt. So that's the same stuff as I'm using here, but just the long version that will go around the whole machine. So ready for another time lapse. Let's go. All right, I just finished doing the belts, and that was absolutely hectic. That really took a lot of time to get the belts in, but now they're in, I'm very excited, because I was really worried about tension and things like that. The belts are kind of a bit wobbly still, but I'm not going to put them under too much tension just at this moment. But if I just spin one of the motors, you can see kind of the strange movements that it gets. So this is just one single motor, and you can see it goes on a diagonal, and the same thing does the other side too. So they've got to kind of work in unison, these motors, to get your lateral axes movement in there. So it's going to be really interesting as I move forward with the project on how it's actually going to be programmed and come together. So what I might do now is I might power it up. I know that could be a bad idea at this stage, but it's getting a bit late at night, so I might just give it a quick power up and just check if I've got the axes in the right direction, and then I think that I'll close it up for the day. But I've been quite proactive today, and I've certainly got a lot done, so this is very exciting. And let's power it up and see what happens. Everything's turned on. I haven't started anything yet, so this could be a bit of a disaster, but we shall see. So I'm just going to clear any alarms there. I'm going to bring down the motion just to something very small. Let's just say 300, and Eek. Let's see what happens. I'll just do a very small movement. Okay, so this is interesting. Alright, so I've got the axes switched around, so X and Y, they're doing opposite things. So I think what I have to do is reverse the motors, or I might even just swap the motors over and see what happens. So, just wait a minute. I'll just turn the machine off. Okay, my setup for FluidNC, I did have one motor set to low and the other one set to high, so they were actually flipping each other's axis. So I'm just going to put them both on high and just see what that comes out with. I'm just going to put that down to 300 again. Let's just go, this is X, so it should go this way. Perfect. Now X, the negative, should go the other way. There we go, very nice. And then we'll go positive Y. Yeah, there we go. All right, so now I've got it. And all I have to do now is speed this up a little bit. Yeah, that's amazing. Sweet. All right, so I still haven't set some of these things. So the belts are kind of like a bit floppy. I can see them kind of moving around a little bit. So I might be able to tension them just a little bit more, but I'm really happy with that movement so far. Oops, I'm just going to stop that for a moment and move backwards, hopefully. So one thing that I've found that's really important as part of a CoreXY build is the belt tension. Now, I haven't tensioned these at all, and that was on purpose, just to see how important the belt tensioning is. And because this has to span over such a large distance, so that's a meter and a half just on each side, that belt does get quite heavy and tends to flop around a bit. So this is day 3 of the build, and so what I'm going to do now is go ahead and tension these belts. So I reckon that I could probably tension them an extra, let's say 40 mil per belt, or even maybe a little bit less, because once you tension one, the other one gets tighter too. So I'm going to go ahead and try and tension it. I'm going to try and pull it together somehow and then screw this in all at once. So I suppose I didn't really think too far ahead about the tensioning system when I designed this, and that's something maybe that I might fix up for a later build. But it seems to be working now, this this belt trap idea, and I might just try and get some clamps and pull that together and then kind of tension it when the clamps have it together. So I'm going to go ahead and create a little jig to kind of pull this together with the clamps, and hopefully nothing breaks in the meantime. Let's get into it. Alright, so I've tensioned this as much as possible. I reckon I could probably put a little bit more tension in it, but there just seems to be a little bit more holding within the belt, so it shouldn't be as floppy as it was, but I'm just going to leave the zip ties on there for the moment. Hopefully I don't crash into the zip ties, but I might need to tension just a little bit more on top of this, but so far that's looking much better than it was. So let's give it a quick test and see what happens, and let's just move it to the side. Okay, that's much better movement than I was getting before. Let's move it forward. So much better. Let's, for the moment, let's do some testing just with this tension. I reckon I'm pretty happy with this tension. It's not too much stress on the machine itself. If I did over tension it, because I'm using 3D printed parts, I am just worried that that will fracture that over time. So hopefully this is enough tension for this belt system. It looks like everything is holding quite nicely. The belts down the side also look quite nicely tensioned as well. So I think this has made a huge difference on the machine. So let's give it a crack at just a basic G-code file that I created. Just makes little squares around the workspace.
All right. Type.
Okay, I'm just going to pause it there because that is looking fantastic. So let's go ahead and snip these zip ties off. And the next trial is to see how fast we can push this thing now that everything is nicely tensioned and essentially ready to go. All right, there's one thing that I had forgotten to do before I push the machine to its limits is probably set the correct steps and steps per millimeter as well for the distance. So I'm going to go through now and just do a really quick calibration. It shouldn't take very long with this type of machine. Alright, so I've gone ahead and calibrated the steps per millimeter. It was way off. It was like for every 1 centimeter it did more than 100 mils. So I've also upped the maximum speed of this to 100,000 millimeters per minute. So that's pretty quick. I don't know what the maximum on FluidNC is, but let's see if this actually works. So I'll go... Okay. Feel like it hadn't reset, so let's just reset the controller. Set this to 50,000. 50,000, so it's going half the speed that I've set it at for the maximum, so hopefully this will... Well, it's pretty quick. That's nice, look at that. Okay. Beautiful. Okay, let's just send it, full send it, all right? So this is 100,000 millimeters per minute. Doesn't seem like, it seems like it's capping out somewhere. So it doesn't feel like that's 100 millimeters per second or per minute. I wonder if there is some type of cap on this, but let's just run a little quick G-code now. The boxes again that I was showing you before, but now it's in the correct measurements. These should be tiny little boxes that it spits out. So yeah, there we go. Okay, that's pretty good. Alright, so it looks like everything is calibrated quite nicely. I've just got to figure out what the maximum millimeters per minute that you can set it on FluidNC, and I'm going to try and cap it out to the top and then set some G-code. Stay tuned, I'll be back in a moment. Alright, so I found the culprit with moving the machine at high speeds was that, unfortunately, this gear here, there has two little grub screws underneath, and unfortunately they weren't secured enough for this machine, so when I was moving at high speeds it was kind of rubbing and spinning freely on this shaft, which wasn't a good thing. So there's a couple of things that I still need to fix on the machine, and one of them would be putting like a flat part on this shaft, just so I know that when those grub screws are tied down that's not going to move anywhere, even if they're a little bit loose. So that's the first thing that I need to replace. There's a couple of other things that I want to upgrade on this machine still, and I'll talk about that soon. So I've been holding off on showing you this next part because I'm really excited about what I've created here. This is a wireless Z-axis system, and that means that this system here is a Z-axis, so it lifts up and down just like a normal Z-axis, but it's powered by a servo motor, and that's all controlled through this ESP32 that I've got on top here. Now, that just acts as a receiver from the ESP that I've got down the front. So my main controller is a FluidNC controller, and that can output a signal for a servo motor. So it's a PWM signal that you can control a servo motor just like a normal Z-axis, and I've been able to hook another ESP onto that output there to send the wireless signal to this one here and control everything. Now, the beauty about that is that this is just powered by a simple phone battery, and that's decently lightweight, sits on the back there. On the front here, I've just got a linear rail which helps pull the axis up and down, and then I've created a very nice little compliant mechanism which acts as a spring just to ensure that when that pen hits the material that it doesn't go through the paper. Keeping things simple, this was a great option to add on to this machine here. So what I'm going to do now is jump in and show you what this does and have a bit of a play. So let's go. Okay, so as you can see here, that these lines that it's been drawing, they all have this little wave in it. Now, I know exactly why those waves are in it and why they're not straight. So if you look over here to the side rails, you can see that the belt that goes all the way down to the back there goes behind this part here. And unfortunately, in the design of it, I did have an idea that that was going to hit, but I didn't really think it was going to hit that badly. So as it's going past, these little belt ripples are hitting on the x-axis here and creating like a little bit of a bumpy motion. So there's some ways that I can fix that, and the first way that I could fix it is I have created these like little rollers, and they just go under behind the belt here, and then the belt goes behind in this part here and pulls it away from the main part. However, I'm not a big fan of that, just because you're pulling in different directions, and once again it's still going to have some slight bumps when it's going to hit these bearings, going over the bearings, just because the bearings aren't big enough, nor does it have the teeth. So if you look back here on how that this is designed, is that it just uses this little this gear here, and you can see that that goes all the way down to the back there. Now you can see there's a huge gap in this section here. Now if I could take advantage of this big gap, because the belt actually doesn't touch the C-beam, the thing that does touch the C-beam is the top of this gear just here. And so if I can just figure out, the front one here is fine, but if I can figure out how to get the back idler somehow clearing this C-beam, I could actually run the belt much closer or within the C-beam itself and avoid from hitting that X-beam at the back there, and I think that's going to solve a whole lot of issues. So I've got some ideas on how I'm going to do that, but unfortunately it just means that I need to dismantle this machine. So I've got some really exciting advancements that I'm going to make with this machine, and the first advancement is actually something that I've reached out to PCBWay for. So these here are my brand new X-beam plates. Now these are for the connecting parts for my X-beam here. Now these have actually been SLS 3D printed from aluminium. Now these are absolutely incredible. I have actually made some small and minor adjustments to these versions of it compared to what I've got on here to better suit the machine and just make sure things run a little bit smoothly. But PCBWay have just been so kind in helping me out here with creating these aluminium brackets, because they are so solid. One of the things that I was looking for is getting a very strong material that was super lightweight. Now unfortunately, when I was considering about getting these done, I was like, oh, this is great because I can get some like really thin infill, and hopefully that would make this part much lighter. But the one thing that I ran into was that even though the infill is at a very light density, unfortunately the process of SLS printing means that it kind of places a powder layer down, it lasers it or welds it together, and then puts the next layer of powder and welds it and builds it up over time. Now the issue with that manufacturing process, which I didn't realize until this moment, was that it actually holds all the powder between the layers, which has created a really not an overly heavy part, but certainly heavier than what I initially considered with these materials. But aside from that, these are going to be absolutely perfect for this project, and I'm really excited because I've never held an SLS 3D printed aluminium part in my hands before, and so I'm really excited to see what these can do and how they respond on this machine. So so this is one of the upgrades that I'm going to be making on this machine. So I'm going to do these ones, plus I'm also going to go ahead and mill out the rest of the plates out of aluminium. I'm really excited about the second version of this machine, and it's been really wonderful to have a bit of a play with this machine and where it's up to for the moment. I think it's been a great little project, but now is the time to refine this machine and make it a super beast of a machine, make it super quick, super strong, and hopefully with some great tolerances as well. Unfortunately, that comes to the end of today's video, and there is so much more to do on this machine to make it the super beast that I want it. Now, I also want to shout out to PCBWay for supplying these plates, and I can't wait to see what happens in the next episode. So if you want to see what happens next, feel free to hit that bell icon, subscribe, and also pop down any comments on how I can improve this machine anymore. So guys, thank you very much for watching, and I'll see you next time.